Okay, so hello everyone. In this video, what I want to do is, so this is for Cal 2, if you're in Cal 2. I decided to do this video to sort of help you out, and we're going to do a few problems regarding area between two curves. This is also for Cal 1, if you do this in Cal 1. I believe they do this in Cal 1 at the very end, but this is mostly for Cal 2, since of course in Cal 2 they do this before they do volume with disk, shell, and washer method. So we want to find the area between these two curves, right? Y equals x squared and y equals x. Now you can sketch it if you'd like. I don't think you would have to like do what is it called, like a perfect sketch. So of course this would be something like y equals x, right? Oops. And then x squared would be something like this. So right here is where, right here and right here is where they both meet at 0, 0, which is the origin, and at 1, 1, right? And if I just color code, so this, let me just do this very quickly. Okay, so this is basically what you know, we want to find this little area here. So let me kind of just color code this one. You want to find that area. And if you guys want me to, so let me actually try to do a better representation of this. Give me 1 second. So for those of you wondering, this is the area that we want to find. Okay, so basically this area here. Okay, so that is what we want to find, and that is basically yes, between those two curves. Now I cannot do Riemann sums for this. In fact, I don't know how to do Riemann sums at all because my calculus teacher never taught us Riemann sums, believe it or not, in Cal 1. So just so you guys know, I'm not really going to be doing anything with Riemann sums at all in this calculus series. So so we want to find that area, right? Now there is a rule that says usually if we have two curves, so let's pretend that, so this is the rule, okay? If we have, so finding the area between two curves, there's a rule for this, and it goes something like this. So if I have, for example, let's just say, I don't know, let me just like that, and then I don't know, something like this, where let's say they both meet right here and right here, right? And these are the points of intersection. These are the points of intersection. So we can call this x2, we can call this one x1, and then this is y1, and then this one is y2, right? And we want to find the area between those two curves, right? So this part. Anytime, and let's just call this f of x, and let's call this one g of x. So that means, and let's pretend that this is, actually, hold on. Hold on 1 second, guys. I need to fix this right quickly. So let's pretend actually that this is A and this is B, right? So that means that, and let me just, let's say this is f of A, and this one is B, right? So, oh my goodness, give me 1 second, guys, I'm sorry. Okay, so I'm gonna try to explain this as best I can. The integral, or the area between two curves is defined by the following. It is the integral from a to b of the higher function. So whichever one is higher, like, what I mean by higher is like above of the above function, if that makes sense. Like the one that is kind of on top of the other one. So the best way I can explain that is, for example, if we have this curve, and then let's say we have this curve, and we want to find the integral from here to here, right? Or actually, like this, right? But this, so, or actually, hold on. I'm trying my best to explain what I'm talking about. And then let's say we have something like this. So let's say we want to find the integral from here to here, right? So from, let's say this is A, this is B. The above function is whatever is higher. So from A to B, which function looks higher? It would be this one. And if we name that as f of x, and then minus the lower one, so the lower one is this one here. This is g of x. So that means that the integral, it would be the integral, or the area of this part would be, so the area of the function, or the area between f of x, where is it? Hold on. Between f of x and g of x would be equal to the integral, and it would be from, let's do color coding. A, and then let this one be gonna do it this way. Hold on, guys. I'm doing my best in terms of trying to explain this as best as I can, because I know that, the thing is, I don't want to, so so the integral from a to b of f of x minus the integral from a to give me a second, guys, hold on. It'd be the integral from a to b of f of x minus the integral from a to b of g of x, right? And both of them would have a dx next to it. So here, so if we want to find the area between these two curves, if we set both equal to each other, x squared equals x, we can find the point of intersection. So x squared minus x equals 0. So that means that x times the quantity x minus 1 equals 0. So then that means that we have x equals 0 or x equals 1. So those are the points of intersection. 1, 1, and 0, 0. Now, the integral would be the following. The integral from 0 to 1 of the top function, so let this be f of x, so be f of x minus, and then let this be g of x. So then it would be, and then be dx. So then you would have the integral from 0 to 1 of, so be whatever function f of x is, so it'd be x, that's the top function, minus g of x, which is the bottom function, or x squared, excuse me. So then you would say, and then dx, and then you would say that this equals to the integral from 0 to 1 of x minus x squared dx. If you take the integral using the power rule, so the power rule of integration would be the integral, so it'd be the integral of x raised to the n power would be x to the n plus 1 over n plus 1. So then you would say that this is equal to x squared over 2 minus x cubed over 3, and it'd be from 0 to 1. Remember that the fundamental theorem of calculus says that the integral from a to b of f of x dx is equal to the quantity f of x, so capitalized f of x, from a to b, so like this. And if I'm taking long, guys, I'm sorry. I'm explaining everything on this video because maybe this is something that you're not fully familiarized with just yet. And so I'm trying to explain it as clear as I can explain it. Minus f of a. So you're going to use that, and then you're going to say that this is really just 1 squared over 2 minus 1 cubed over 3 minus 0 squared over 2 minus 0 cubed over 3. So it's going to be 1/2 minus 1/3 minus, and then this is just 0 over 2 minus 0 over 3. So you have 1/2 minus 1/3 minus 0, which is just 1/2 minus 1/3, and then you do, so it's going to be, that's equal to 3 minus 2 over 6, which is just 1 over 6. So the area would be 1/6. And that is your answer for this. That is how you find the area between two curves of a function, or between two curves, really. So yeah, if anybody has any questions, let me know. I know this video took a little long. It's only because I was explaining the terminology behind it, and yeah. So because I mean, obviously we have not gone over this yet, and for those of you who are looking for those of you in Cal 2, I'm just trying my best to explain this if you've forgotten how it's done. So yeah, if anybody has any questions, please let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.